You ever stop and think about the electricity you use, where it comes from? Well, here's a wild thought for you. A big chunk of the power that's generated at a power plant, it never actually makes it to your house. Nope, it just vanishes along the way, lost in this huge web of wires and transformers. So today, we're going to play detective and solve the case of the vanishing kilowatts.
And look, this isn't just some abstract engineering problem. That lost energy, it has a very real cost. A cost that, you guessed it, shows up right on our bills. So the big question is, why are we paying for power that disappears before we can even flip a switch? Let's dig in.
All right, to get our heads around this, let's think of the entire electrical grid as a giant sprawling plumbing system. But it's a really leaky one. First up, we need to understand exactly what this energy loss is and why it's such a massive headache.
So what is energy loss, or EL, really? It's actually pretty straightforward. Picture a power plant pumping, say, 100 gallons of electricity into this giant pipe system. By the time it travels all those miles to get to your home, maybe only 95 gallons come out. That missing 5 gallons? That's the energy loss. It's power that was made but never got to do any work. It just, poof, gone.
And these leaks, they hit us in 3 big ways. First, and this is the one we all feel, is the economic hit. Power companies aren't just going to eat that cost. They pass it on to us. Second, there's the regulatory side. Authorities can slap some serious penalties on utilities if they're being too wasteful. And finally, and this is a big one, there's the environment. Every single kilowatt that's wasted means we burned fuel and pushed out emissions for absolutely no reason at all.
Okay, so if these leaks are so obviously bad, you're probably thinking, well, why don't they just plug them? Yeah, if only it were that simple. See, first you have to find the leaks. And it turns out, trying to measure energy loss across a gigantic power grid is unbelievably difficult. And you guessed it, super expensive.
So for the longest time, utilities have basically had 2 bad options. The hard way is to go out and install thousands and thousands of expensive meters all over the grid. We're talking a logistical and financial nightmare. The other option, the complex way, is to build these incredibly detailed computer models. But that takes a mountain of data and a whole team of experts, making it just totally impractical for checking the whole system.
But what if there was a better way? What if you didn't have to measure every single drop? Well, some researchers came up with a new approach, a much smarter and way simpler method to just estimate where the biggest leaks are hiding.
The secret sauce to this whole thing is a concept called the load factor. And the best way to think about it is to imagine a restaurant, right? If that restaurant is totally packed from open to close, its occupancy rate or its load factor is super high. But if it's only got a crazy rush for an hour at lunch and is dead the rest of the day, its load factor is really low. The exact same thing applies to a power line. Is it working hard all day or just for a few peak hours?
Now, the next piece of the puzzle is the loss factor. And what's so cool is that it's directly tied to that load factor we just talked about. Think about it. The more sporadically a system is used, like our restaurant without 1-hour lunch rush, the more inefficient it is, and the more energy it loses is heat. So the genius part is, if we know the load factor, which is actually pretty easy to measure, we can make a really good guess at the much harder to measure loss factor.
And this brings us to this really elegant 4-step process. First, you model a standard 1-kilometer base case of a power cable. Simple enough. Second, you use that model to create a master formula that predicts energy loss. Third, you just use a simple correction factor to tweak that formula for any real-world cable, no matter the length. And finally, you just add up all the estimated losses. It's like doing a full system-wide audit, but without all the expensive meters or crazy simulation.
Of course, a clever idea in a lab is one thing, but does it actually work in the messy, complicated real world? Well, that's what the researchers wanted to know. So they took their new method and put it to the test on an actual, live power grid.
The proving ground was a medium voltage network in Bandar Sagamat, Malaysia. And this wasn't some tiny, simple setup. We're talking about a complex, real-world system with over 100 kilometers of cable, 10 main power lines, and more than 150 transformers powering people's homes and businesses.
So the moment of truth. How did it do? Well, check this out. The new simple estimation method, it predicted a total loss of about 212 megawatt hours. And the old, super complex, time-consuming simulation, it came up with 227. I mean, look at those numbers. They are incredibly close. This is the proof right here that the simple idea actually works. So what does this all mean? Why does a simpler way to do a calculation even matter? Well, because the payoff here is potentially huge. This is a really big deal.
You know, the researchers themselves put it perfectly.
They said this method is a game changer, especially for utilities that just don't have the money or resources for a massive network of smart meters. It gives them a real practical tool to boost their efficiency, which is especially important in developing parts of the world.
And the accuracy is what makes it so useful. We're talking a difference of less than 10% compared to that massive complex simulation. That is more than good enough for a utility to figure out how much energy they're losing and, more importantly, where to spend their money on upgrades.
So, the bottom line is this. This simple technique gives power companies a fast, cheap, and reliable way to find their biggest leaks. They can finally go in and strategically fix those leaky pipes, which saves money, lowers our bills, and cuts down on needless carbon emissions. It's a win-win-win.
And that really leaves us with a bigger question, doesn't it? We so often think that to solve these massive, complex problems, we need even more complex, expensive technology. But in this case, the case of our vanishing kilowatts, a simple, clever idea turned out to be the best tool for the job. It really makes you wonder what other huge challenges out there could be solved not with more complexity, but with just a little bit more elegant simplicity.